Okay, we're going to look at equations for perpendicular bisector. We will address this segment or this equation or how to come up with the equation again with special segments in a triangle. Perpendicular bisector, just break down the term. Basically, a perpendicular bisector is a line, segment, or array that is perpendicular and goes through the midpoint. That's the bisector part. So two characteristics of a perpendicular bisector. One, it has to form right angles. That's why it has to be perpendicular. And it has to go through the midpoint. That's the bisector part. Okay. All right. These characteristics in the coordinate plane are going to be related as the following. If it's going to be perpendicular, then you're going to have to see opposite reciprocal slopes. And to deal with the midpoint, you're going to have to use the midpoint formula. Okay, which is basically x1 plus x2, the average of the x coordinates divided by 2, and then y1 plus y2 divided by 2. So what you are going to be, or what we're going to look at or use are their steps to find the equation of the perpendicular bisector. And there are 5 steps, but really need to know the 4 because the 5th one is just all depending on what type of equation form they want the bisector. So the first step is to find the midpoint of your segment. Here we're doing AB. So to find the midpoint, we're going to use that formula with, I said, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And we're just going to plug it in, and we're going to solve it. So our x's would be 2 and 2 divided by 2, and 5 and 7 divided by 2. But once I simplify this, this would end up being 4 divided by 2, 12 divided by 2. So the midpoint, the coordinate of the midpoint would be 2, 6. That would be our midpoint, and for a midpoint. So the second step is we're going to find the slope of that segment AB. To find the slope, we're going to use the slope formula, which is y2 minus y1 over x2 minus x1. So we're just going to plug it in. That would give me 7 minus 5 over 2 minus 2. Well, 7 minus 5 is 2 over 0. Well, because the 0 is at the bottom, we have what we call an undefined slope. So the slope of AB, that is your symbol for slope, is undefined. Our abbreviation for undefined is UND. The third step will be to find the perpendicular slope. Well, since I already know the slope is undefined, the perpendicular slope would be 0. Okay. Basically, since we have an undefined slope, that means that the line would have to be vertical. Okay, this is a vertical line. Well, if I want to do perpendicular to that line, that would have to be a horizontal line, which would mean it would have a 0 slope. So now we're going to use point slope form to write our equation. When we use the point slope form, you're going to use your point would be the midpoint. We're going to use the midpoint, And in our example, our midpoint was 2, 6, I believe. Yeah, midpoint was 2, 6. And then we're going to use the perpendicular slope. And our perpendicular slope was 0. So we're just going to plug it into our form, which is y minus y1 equals m parentheses x minus x1. So when I plug that in,
students, at this time you must exit the building. Failure to exit the building may
y
result
minus
in
6
consequences. We appreciate
equals 0
cooperation.
parentheses x minus 2. And we are going to distribute because we want it in slope-intercept form. Well, anything times 0 is 0. So basically we have y minus 6 equals 0. And we want it in slope-intercept form, which means we're solving for y. The y has to be by itself. Mx was b. So if I'm going to solve for this for y, I add 6 to both sides. And I would get y equals 6. And now we have it in slope-intercept form. So these are the 5 steps you need to kind of memorize to put it in perpendicular bisector equation, meaning we must have the midpoint and we must have the perpendicular slope and then use our point slope form. So a way to check your information is to graph it and do some problem solving. So we knew that A was at 2, 5, which is here. Here's my A. And B was at 2, 7. Which was right here. Oh, right here. Wait, I guess that negative 2. Sorry. 2, 5 here and 2, 7 here. So there's A, B. Alright, there's your segment. Alright, I can see that that segment is vertical, so its slope is undefined. I can physically count, this is 1, 2, and see that that point is the midpoint. So the midpoint would have the coordinate I can check on the graph, 2, 6. And I see that its equation has the slope of AB is undefined. So that means the perpendicular slope, if I have to go this, let me change color. We're going through that midpoint, going that way, which will show that it is 0. And since that is a horizontal line, then that lets me know it's y equals where it crosses the y-axis, which is 6. And so you could use the graph to help you problem solve, or you could just remember your five steps. So on the next example, I gave you the graph to problem solve, but I also want you to practice the 5 steps. So the first thing you're going to do always is the midpoint. All right, to find the midpoint, I'm going to take the average of the x-coordinates, so negative 2 plus 4 divided by 2, average of the y-coordinates, negative 5 plus 1 divided by 2, and then come up with its coordinate. So that would give me 1 and a negative 2, I believe. So that would be a negative 4. Yeah. All right, so that's our midpoint. Second, we need to find the slope. We're going to use the formula, rise over run. So that's 1 minus a negative 5 over 4 minus a negative 2. And then when I simplify that, that will become 6 over 6, which is 1. But for a perpendicular bisector, we are going to use perpendicular slope, which is negative 1. So I'm going to focus on my perpendicular slope and my midpoint to come up with the equation of that perpendicular bisector. So step 4, I'll have to come over here. The 4th step is we're going to use point slope form. We're just going to plug it in using the midpoint and using the perpendicular slope. So this would be y plus 2 equals negative 1 parentheses x minus 1. And then if I put it in slope-intercept form, I'm going to distribute. So I get y plus 2 equals negative x plus 1. Negative x plus 1. And then if I subtract 2 both sides, y equals a negative x minus 1. And is my slope-intercept. So that is our guided practice for example 1. We can also do the same thing for example 2. In class, we kind of really focused on the number 4, or number 3, excuse me, because I wanted you to be comfortable with getting fraction answers. So we're going to go through the same steps. First, we do our midpoint. Our midpoint is our average of our x coordinates and our y coordinates. So it's 1 plus 3 divided by 2. 7 plus a negative 3 divided by 2. We get 4 over 2. And we get 4 over 2. And so our midpoint, yeah, 2, 2 is the midpoint. Then we look at the slope. We're going to do negative 3 minus 7 and 3 minus 1, and then simplify that. Negative 3 minus 7 would give me a negative 10 over 2. So the slope is negative 5. But step 3 says that we are not going to use that slope. We're going to use the perpendicular slope, which is 1/5. So we're going to focus on the perpendicular slope and the midpoint, and use that to plug it into, oops, I didn't mean to do that, into midpoint point slope form. So over here, we'll say y minus 2 equals 1/5, parentheses, x minus 2. We're going to distribute and solve for x. So that'll be y minus 2 equals 1/2 x minus 2/5. And then we're going to add the 2. Well, when you're adding the 2, you need to make this 2 into a fraction with a common denominator of 5. So 5 is it's like 2 over 1. So 5 is my common denominator. I would have to multiply the top and the bottom by 5, which gives me 10. So I have basically a negative 2/5 plus 10, which would equal y equals 1/5 x minus 8/5. And yes, you can have a fraction y-intercept. So that was us practicing and using the midpoint and the perpendicular slope bisector. Okay, in our last couple of guided practice problems, we are going to use our graph to help us problem solve and see if maybe you remember the concept of lines of symmetry or what that means. So they want us to first plot our rectangle with the following vertices. We have 0, negative 4. We have negative 4, 4. So negative 4, 4. Then 0, 6. And we have 4, negative 2. So I'm going to create that rectangle. And our rectangle is kind of rotated a little bit. We're going to determine the equation of the two lines of symmetry of the rectangle. A line of symmetry is basically like your line of reflection. Or if I was to fold on that line, I would have two congruent pieces exactly reflecting each other. So we had basically two lines of reflection. And if it's a line of reflection, it's going to have to go through the midpoint to have two congruent parts. So I know my line is a little bit off here. So that point and that point would be the midpoint of that segment. So that means that my line is going through those 2 points. And then I would have the midpoint, it should be here and here. And I'll draw that. And we have a line going like such. Okay? And my lines are a little off, but I'm hoping you can see what the line of symmetry is. And so they wanted to determine the equation of the line for these two lines of symmetry. So we have line 1 and we have a line 2. So we are going to come up with the equation. And the easiest way is just keep it in mx plus b form. So I can find the slope using my rise over run and my b as my y-intercept if I see where it crosses the y-axis. Well, on this one, my drawing is off, but it's the y y-intercept is at a positive 1. So we should have y equals, and I need to come up with the slope. Well, this line is decreasing from left to right, so I'm just going to count between that y-intercept and that midpoint of that side. This would go down 1, 2, 1, 2, 3, 4, and then to the right 2, down 4 would be negative. So we got negative 4 over 2x plus 1. Well, we're going to simplify that. So just do y equals a negative 2x plus 1. So that is the equation for line 1. I'll put 2 over here. Sorry. For line 1. Line 2, well, if I look, it has the same y-intercept, so I just got to figure out its slope. So again, I'm going to go through the 2 midpoints. That would be up 2 and then over 1, 2, 3, 4. So it looks like it's a positive 1/2 x plus 1. And so now that we have the equations for those 2 lines of symmetry, this was y, sorry. Line 2 has the equation of y equals 1/2 x plus 1. They just want us to determine the points where the 2 lines of symmetry intersect. That would be at 0, 1. You can see that on the graph. So just remember, understanding lines of symmetry is also dealing with midpoints that we would use on perpendicular bisectors. So that's, you can do that physically on the graph, or you use the midpoint formula. And then notice the relationship between this slope, a negative 2, and that slope, 1/2. Those slopes are perpendicular, and which is why we use our perpendicular slope for a perpendicular bisector. So, hopefully this helps you understand perpendicular bisectors a little bit better. And you can go through the steps that were on the guided practice attached with the file.